Today, Vishal had to walk all the way home because his car ran out of fuel. Vishal's car runs on CNG and he couldn't find a CNG station where his car ran out. Ever wondered where fuel vanishes from our cars? Do fuel molecules get destroyed while providing energy for the car to run? Well, as per the law of conservation of mass, matter can neither be created nor destroyed. It can only be converted from one form to another. So, we can say that fuel molecules don't get destroyed after providing energy to the car, but they simply change form. How does this happen? Let's look at the chemical changes that happen inside a fuel tank. CNG stands for compressed natural gas and it mainly contains methane. When methane burns in the presence of oxygen, the atoms present in methane mix with the oxygen and reshuffle to form new groups of carbon dioxide and water. The total number of atoms remains the same and a lot of energy is released in the reaction. Here's the chemical equation for this reaction. As you can see, the number of hydrogen atoms on the reactant side is less than the number of hydrogen atoms on the product side, which according to the law of conservation of mass is not possible. Therefore, we must balance the reaction by making the number of atoms equal on both sides. To balance it, we must add 2 extra hydrogen atoms on the product side and 1 oxygen atom on the reactant side. Let's first balance the hydrogen atoms. Remember, we cannot change a compound's chemical formula while balancing an equation. So, to add hydrogen atoms on the product side, we'll multiply H2O by 2. We have now balanced the number of hydrogen atoms, but the number of oxygen atoms on the product side has increased to 4. To balance the number of oxygen atoms, we'll multiply the oxygen molecule on the reactant side by 2. We now have equal numbers of atoms of every element on the reactant and product side, and with that we have balanced the equation. Now we know where fuel vanishes from our vehicles. Well, it doesn't really vanish, it gets converted into carbon dioxide and water vapor.